This problem involves 3 variables and 3 equations. And I've tried to make it a little more realistic, and so it turns out that some of the numbers are kind of high. But we have a calculator. It shouldn't be that big a deal. So let's read through it first. A beverage company markets 3 types of juice mixes. The following table shows how many ounces go into each pint bottle. Alright, so we have a mix A and a B and a C. Not too creative on my part. And they mix apple juice, orange juice, and pineapple juice. And I have no idea if any of these would taste any good at all, but anyway, I've just made up the numbers. Going across the apple line, there are 5 ounces of apple juice in mix A, 7 ounces in mix B, and 2 ounces in mix C. And then 3, 5, and 7 for orange juice, and 8, 4, and 7 for mix C. Now, they currently have 8,419 ounces of apple juice, 9,009 ounces of orange juice, and 10,556 ounces of pineapple juice on hand. How many pints of each can they produce in order to use up all the juice? Alright, so where should we start with this? Let's define our variables. So I'm going to do a little bit of erasing. I always think it's a good idea to define the variables we're looking for in this problem. And let's stop and think. Are we looking for apple juice, ounces of apple juice? Are we looking for bottles of mix A? Well, we know how many ounces of apple juice we have. We have 8,419 ounces of apple juice. So we're not solving for the ounces of apple juice. We're solving for how many bottles of mix A, B, and C. And if you go back and look at the question I had down here, that's exactly what it's asking for. So the question in these problems always really lets you know what variable you're looking for. Alright, so let's let A be the number of bottles, number of mix A bottles, and then B would be the number of mix B bottles. C is the number of mix C bottles. Now then, we have to come up with some equations, and there are 3 unknowns in this problem, so we need 3 equations. And our 3 equations will come from these numbers. Again, why is that true? Because when we use up all this fruit juice, the amount of apple juice used in the 3 mixes has to total 8,419. The amount of orange juice in the 3 mixes must total 9,009, and so forth. So that defines the 3 equations we're looking for. So I need to make some room here. I wish I had a little bigger board, but let me just start an equation here. For the apple juice, how many ounces of apple juice are used? Well, for each bottle of A, there are A number of bottles, each bottle contains 5 ounces. And then for each bottle of B that we mix up, that contains 7 ounces of apple juice. And for each bottle of C, there are 2 ounces of apple juice. So this is all apple juice. It adds up to 8,419. Alright, so you can see this with the units. Like for example, 5A. 5A really means 5 ounces apple juice per bottle. And A is bottles, number of bottles. So the word bottles cancels out, leaving ounces of apple juice. That's why 5A gives you apple juice, 7B gives you apple juice. Altogether, we total up 8,419 ounces. Alright, so that's sort of gets you started, and once we have that equation down, the other 2 equations will fall into place. But here I want to be a little careful, because I don't want you to oversimplify these problems. If you see information arranged in a chart, it doesn't mean that you form your equations going across the chart. Sometimes the information is arranged differently and you go down with it. In other words, these numbers appear as coefficients in these equations, but do we go across or do we go down? You'll just have to look and be careful. It could go either way, depending on the problem. Alright, so I'm going to try to write the equations in. Let's see. I do have my information written down here, so I'm going to erase everything. And but our first equation is 5a plus 7b plus 2c equals 8,419. The next equation will be 3a plus 5b plus 7c equals to 9,009. And then we have 8a plus 4b plus 7c equals to 10,556. So the three equations are all going to be very similar to this one right here. Alright, so I'm going to make some room on the board and we'll go solve the problem. So you see I copied the three equations down that we need to solve, and this one again came from the total amount of apple juice that was on hand. This one came from the total amount of orange juice, and pineapple juice was the last equation. Now I realize I'm taking a little bit of a risk here, putting a problem with such large numbers in it. I don't want you to be intimidated by that. Everybody has a calculator. Let me go find mine. There we go. And so it's going to work just like any of these problems, except we'll probably want to use a calculator. Alright, so let me label these. This is equation 1, 2, and 3. And what letter should we get rid of? Well, let me suggest that we get rid of C, because these numbers are equal here, so if I subtract these equations, we can at least start off by eliminating C. So if we take equation 2 and subtract equation 3, just from the way it's written, 3a minus 5a is minus 5a, 5b minus 4b is plus b, the c's cancel, and this equals to a negative number. And what would that be? Probably 1,047, I think. Let me just verify that. 10,556 minus 9,009 is 1,547. Did I say 1,000? I meant 1,547. But it's negative because I have this number minus a larger number is minus 1,547. Alright, so there's the first combined equation, eliminating